Hello, everyone. Good morning.
Yeah, hello, good morning.
Yeah. Hope you're all fine.
Yes, I'm good. I'm good.
Okay.
Sad, Alpha.
I'm fine, sir.
That's great. Today's class is going to be different. We're going to be, after looking into every concept, we build at least 2 projects to at least see how those concepts can be applied in at least solving problems, so we can get a clear understanding of what we're actually doing. So today we're still on advanced JavaScript concepts, and we are going to be looking at symbols, iterators, and generators. And the first one on the list are symbols. Symbols in JavaScript, as you can see, are primitive data types introduced in ECMAScript 6. That is A6 2015. It was introduced in 2015. And they provide a way to create unique identifiers that are guaranteed to be unique and immutable. Symbols are often used as property keys for object properties, allowing for non-colliding private or special purpose properties. And JavaScript symbols are primitive data types. They are immutable and they are always unique. If you create 2 symbols that are the same, you can see that the same, but they are actually different. Like if creating symbols, let's jump into creating symbols. Actually, we're going to be naming our file as test.js. If you want to create a symbol, go with, let's say, symbol is equal to symbol. And let's say this is a name. And let's create a second one. Symbol2 is equal to symbol. Let's give it a name also. These 2 symbols are not the same. Let's test it out. Is exactly equal to symbol2. Sorry. CD on symbol and not test. As you can see, the log function is returning false because the first symbol and the second symbol are not the same. Though value 1 and value 2 both they contain the same description, but they are different. That's how symbols work. Like creating a symbol, you use the symbol function to create a symbol. Like for example, you can simply say symbol is equal to symbol. And then you can log symbol to the console to see what you've got. Then you can even log the type of symbol to see the data type. See, symbol is actually, it's a function, but it's a symbol. Function returning a symbol. And type of symbol is supposed to call this. Yeah. It's a symbol, and the type of symbol is symbol. It's not returning any other data type like objects or strings or whatsoever. A symbol is a symbol and it's always unique. So you can also access symbol description. To access the symbol description, we use the dot operator. Like we have a symbol of name, and we want to actually access the description here. The description is the name. You can simply say log symbol.description. It will return the name. So that's how to access the description of a symbol. Always have it in mind that symbols are unique. If I create another symbol with a name, that doesn't mean they're the same. They are totally different. Very, very different. Okay, Joshua, you can go ahead.
Okay, what I wanted to ask, objects are stored by their references. Does it mean that it's also stored by, like, it's also it's also referenced like somewhere in the memory?
No, as I earlier said, a symbol is a primitive data type. Primitive data types are stored by value, not reference.
Okay.
But they actually behave like objects, but they're not really objects. This, you can see, it is called, it's not an object literal. We used a function to invoke a symbol, but it's not really an object, and it's not stored by reference, it's stored by value. And that is the reason why they are unique. If they are stored by reference, they won't be unique, because two different references will refer to the same object, you understand? So they are stored by value. Yeah, they are stored by value. They are primitive data types.
Okay, thanks.
Yeah, you're welcome. So let's move ahead and see how we can use symbols as object keys. And this is where the foreplay comes in. Symbols are useful in objects in the sense that you can use them as object keys without mutating any data. Let's say we have a symbol of ID. And we have a person and a person object of name. Let's say Joshua, and ID of let's say 1, 2, 3, 4, 5. As you can see, we're using symbols in objects. We don't just we put them in an array. Let's say this is an array, not actually an array, but we're using symbols in objects. This is how we represent them, like this, and not just like this. So if you try to access this now, let's say we want to log, let's log the person to the console and see what we've got. Name Joshua, and the symbol, the ID is actually a symbol, as you can see. And symbols are not included in the for in loop. Let's say, for instance, we want to loop over the keys of this object. Now, we want to loop over the keys of this object. Let's include an age property of 612. So Joshua is actually 612 years. Oh, wow. Such an old man. Joshua is old. And let's key in person. And want to log the key to the console. As you can see, there's no ID. We're only seeing the name property and the age property. So this takes us to some couple of questions. Why are we not seeing the ID? Because symbols are private. When working with an object, JavaScript objects don't have private properties. So sometimes you have to use closures to make some properties private. But when using symbols, you don't even need to use closures. You can simply write your object, use symbols as properties, and process some kind of data and do whatsoever work you want to do without worrying about private and public properties. And so let's move over to benefits of using symbols in objects. If the same code snippet is used in various programs, it's better to use symbols because, yes, Joshua, go on.
Yeah, sorry. Does it mean that when you look through an object that has a symbol, you any like any kind of loop, it's not going to show up
No,
since
it will
it's
not show up
private.
because it's private. Yes.
Okay, okay,
This here is trying to say this is a private property and you cannot access it.
okay, okay,
Yes, you cannot access it. You have to write some logic that will return this ID. So if you really want to access it, but accessing it directly is not allowed because it's a private property. And that's how private properties work in object-oriented programming languages like Java and the rest. But JavaScript is type-less and everything is exposed. So we don't have private properties in objects except to use some kind of closures or we use symbols, as you can see. And as I
okay,
was saying, yeah, it's because you can use the same key name in different codes and avoid duplication issues. Yes, you can use ID here. And if you want to reuse this code in another code base, you can simply import it and use it without worrying about colliding IDs because symbols are different. The ID here has a different value than the ID in the code base you are using this code in. So you don't have to worry about colliding issues and all of that. Now, if the other program needs, let's say we have this ID here and the other program also needs the property name ID, you just add a symbol name ID and you won't have duplication issues. Not at all. Because both of them, they have different values. So they're the same properties ID, but using symbols, they have different values as we demonstrated earlier. Now let's try to, when you're using strings, if you remove this and try to reference your ID here directly, let's assume you are assigning this property ID to this value directly and you want to use this code in another code base. You have collision issues because let's assume this another ID property in that code base that they're using to perform some kind of processing. I also have an ID here. They will collide and possibly it depends on where your code is placed. You may override the property of the ID in the other code base, or that may override yours and it will become a problem. Your code will not work as expected. Here. Your code will not work as expected. So we've seen, yeah, Joshua, you can go on.
Yeah, so in other words, when we are going to specify a field like that, we have to put it in this bracket, right? This square bracket.
Yes, in order to make it unique for the developer experience. And if you know it's been done that way, anywhere you see it like that, you know that yes, this property is actually a symbol. You understand?
Okay, okay, okay. Sorry, can you like the way you specified that ID in the symbol instance, this line one, can you have like destructure it and maybe you have like multiple symbol value or symbol key in the object, in the person object, maybe age and ID or something.
Okay, age and ID. You want the IG to be a symbol also?
Yeah,
Like the age.
like the age as well. So
Okay, you can make the age a symbol by saying,
okay, okay,
yes, age.
okay, okay,
So
okay.
then you come here and then now if you log this to the console, you have name and ID, but the age is now a symbol. So it's private. It's private and you cannot access it. And see what happens if I remove this. This is no longer a symbol. So it's accessible. It's now public. To make it a symbol for readability and for JavaScript to know that, yes, you are referencing this symbol here, you just put it in a square bracket like this. And it becomes, you are referencing this symbol here and it becomes, this value is assigned to this key. And you cannot iterate over it. It now becomes private. Okay, let's jump to symbol methods. We're actually going to be building two projects here, symbol-based access control and symbolic configuration manager. So we understand better when we build project with it. Projects phase in every. So the symbol method, we have different symbol methods, but we are not going to be looking. We're not going to be looking all. We're looking at them all. We're just going to be looking at few. We have the four method that searches for existing symbols. We have the key for method that returns a shared symbol key from the global symbol registry. Like something like, let's see, let's symbol equal to symbol name. So you can, without doing this, you can use this symbol global. You can say symbol dot for. You can say returns a symbol object from the global symbol registry matching the given key if found. Otherwise, it returns a new symbol with the key. So you are giving, let's give it a key of a name. Now, let's try to access it. Let's get the key for name. Let's say log, oops, symbol dot key for this symbol we just declared. And it's returning name. We've defined this symbol and we're giving it a key. This symbol is for name. So if you want to really get the key for this symbol is name. So we want to get the key for this symbol, just say let console.symbol.key for the symbol we've just defined here, and it will return name because that is the key for this symbol. But now this symbol is in the global registry, so you can access it anywhere in your code base. And let's say we want to say let log symbol dot key for, you see, age. Age is not a symbol. Or let's say put it directly. Age, it will tell you that age is not a symbol. Age is not defined because it has searched for it everywhere in the global registry and it cannot find a key for this value you are giving. So it will throw an error that age is not a symbol. Actually, another method, let's talk about, we have different methods. We have four, key for, to source, to string, returns a string containing the description of the symbol or value of. You can actually say log symbol dot value of, I think this is the right syntax. Query, you can see it's returning symbol name. The value for this symbol is the name. Actually, the value is, it's a kind of hidden, and accessing it now, we've not assigned any value to it. We just assigned, you just created this symbol, but value to it has not actually been assigned, but it's expecting a unique value. So we can even say symbol dot to string. And earlier we did something like log symbol dot value of. As you can see, this is green. That means not a string. Well, to string, it will return the value and then convert it to an actual string. So the symbolic methods, we have the for. That is the first one. For key for to source to string and value of. You can actually go ahead and play with it if you wish to. Can apply this method on a symbol and sorry, this is to not TP to perform any kind of operations you want to perform. This takes us to symbol properties. Symbols also have properties. Properties where you can apply to perform different functions and other things. We have a lot of them, about 8, 7, 9 of them. We have the async iterator. The has instance is concat spreadable iterator match. Let me just try to like list them for you. These are the methods. And we're going to be having this. These are the methods. And these are the properties. We have the async iterator. Which one again? We have the has instance. Iterator is concat spreadable, and we have match search, replace all, replace split species, split species, description to string, tag, and to primitive. Yes. I think these are all the properties. Maybe. Okay. So now we're going to be working with just one of these properties. So you feel free. I'm going to be pushing this repo to GitHub. So you feel free to clone it and then try to test out all of these properties on your own, experiment with them. But we're going to be testing the is concat spreadable property. Yes. Let's see how it works. Let's say we'll have yes. Let's try to concat two arrays. So we have constring array is equal to A, B, and C. Then we have a number array of 1, 2, 3. Now, if you want to concatenate this, you can actually do it. You see log string array dot concat number array. And you can see it is concatenated. But let's say you want the string array to be the top level array, and you want the number array to be included in the string array as an array on its own, like a sub array. what you can say is number array, then you say symbol dot is concat spreadable, then you set it to false. Because when you concatenate this thing, you spread it. It's the same thing as saying string array, then, sorry, calling the string array here, then actually spreading the number array, something like that. So if you do that, this is the result you get. But if you set this to false and try to log it to the console again, oops, is there a mistake somewhere? It's actually what's happening. Number array symbol that is concat spreadable to false. String that's concat number array. So what is happening here? Okay, we're actually getting the results, but it's like there's an error somewhere. As you can see, we have a sub array of 1, 2, 3, but then the symbol that's concat spreadable is callable. I think it's callable. It's a property. Our result is correct, but then let me see all this. Oh, it's not a function. This is a property. It's not callable. But then why is it still including 1, 2, 3? We are getting our required results, but then at the same time, we don't want this symbol that. Because this is a property, and if you say const x is equal to symbol x, now if you say log x dot description, and you are simply getting your x. So we're really supposed to actually get symbol that's concat spreadable to false, and then you know what? I don't think, because this is not, it's an error somewhere, but I'm really gonna leave it up to you to like debug it later and find the results all by yourself. Yes. Our desired result is here a sub array, but then this is not supposed to be included. So maybe you debug it later and find the result all by yourself. So in review, we've tried to understand symbols, how to create symbols, how to get the value of symbols, how to convert symbols to string. We discussed the method, the for, the key for, the to string, it sort value of, and all of that. But learning all these concepts without building projects can sometimes be like confusing. So when you apply them in building projects, you actually get to understand how they are applicable in real life and how you can use them to actually do some kind of things. So let's jump into building like these two projects with symbols. Let's actually build a symbol-based access control. And what this is going to do is it will manage permissions for different users. Like for it will have roles and permissions like the admin and the user. If you're not an admin, you will not be permitted to like carry out for some functions. Some functionalities will be restricted if you're not an admin. Or if you're an admin, you get access to writable, deletable, and readable permissions. If you're not an admin, you can only read content. So let's jump into creating this. Let's actually give it a name of symbol-based access control.js, not JSX. This is not React. That's JS. Okay. So now the first thing we're going to do is we're going to define a symbol for different permissions. But first of all, we define a constructor function for row. We have a function row, then we take in a name and permissions. Then we initialize the name and the permissions. Oops. What's happening here? Show permissions. So let's create a symbol for read. Read permission is equal to symbol read, and write permission is equal to symbol write. And then we create an admin role and a user role. Const admin role is equal to new role, an instance of the role constructor function. We pass in admin as a name, and then we pass in an array of roles. We have the readable permission and the writable permissions. We create another instance of the role object, and then we pass it, we make it a user role is equal to new role of user. Then we only pass in the readable permissions. Now we use this to create an authorization system. Like we define another constructor function, an object of user that takes in a name and rows. Now we assign the name to name and rows to rows. And then we want to actually pass in the admin user and the regular user. You know, we're doing this manually now. It's not an application where you can actually use forms to perform things on the go. We're actually implementing this manually. So we we've implemented it, we have to make use of it and see how it works. So the admin user is equal to new user with admin user, an array of admin row. Actually, let's just copy this and paste and give it let's say regular user with a regular user with the row of user row. Now let's try to gain access to this system. We've built a system now. We actually built a row-based system where only admins have permissions to read permission and write permission. They only have permission to read and write to the system, while users have permission to only read from the system. Let's say like a blog system where admins can post and edit post, but users can only read the post. So now we've created a user object where we can create different instances of the object. We have the admin user and the regular user. So let's assume the admin user is logged in and another regular user is logged in. Then we create a function. Let's say this is the authentication system. Let's say access or gain access or can access in short, which takes in the user and permission. Then what it does is it returns a higher order function that checks if a user has user.rows.sum. This is a higher order function that takes in a row and checks if the row permissions. That include permission. Return, no returns. Then we come down here and we say log access. Sorry, can access admin row. No, is it admin row, admin user, not row. Admin user with read permission. Then we're checking if the admin has the permission to read. Then we'll also check if the user has, like says, if the regular user has the right permission. Let's log this to the console and see if application works. Oh, let's, no. We're actually checking a different file. Node. Oh, this name is long. Access what? I've forgotten the name. Access control.js. Symbol-based access control.js. Oops, kabli. We're getting row of permissions that include is not a function. Row, some row the permission that includes. So what's happening? User.rows. This user here is the admin user. And the rows here is the admin row. The admin dot includes. Yes, this is actually an array. User the rows, some row. Row dot permissions. that includes TypeScript. And this is the reason why TypeScript is useful. We're spelling this wrongly and JavaScript can notify us. That includes Kabli again. Use of the rows of some canary properties of undefined reading sum. Oops. You mean it? Use of the rows of sum. Sum is a higher order function, and we're trying to check if the rows here, rows of a user is passed in as an array. Oops. So the rows of sum. Yes. Some row that includes permission. Okay. Let us debug this thing. Yes. Let us debug this thing. This thing is not working. Log user permission. Okay. So now we call can access. We'll pass in the admin user and we pass in the read permission, and then we call the function. Oops. Yes. Rows is having a row of name, admin, and permissions of an array. User is a symbol, the name admin. So admin view. So now let's see. User dot rows. Let's just log user dot rows and see again where our error is coming from. User dot rows, and we have name, admin, permissions, read and write symbols. Yes. That permissions. Is this correct? No. Yes. Undefined symbol read. So that's row log row. False symbol read row admin permissions. Row dot includes. Let's say row that includes permission that is passed in. We're getting a Kabli. Row that includes is not a function. But initially what we got here is logged row. And why is this giving us problem? We are supposed not to be here by now. Oops. Yes. So let's fasten the process. What error is it? What is this? Expected. Is it here? Oh, well, why are you showing me this? Why are you showing me this? And this is why I love TypeScript. Okay. A closing parenthesis. Yes. And that's where the error is coming from. Yes. We have a user that rows with some row, console the row. The permission here is false. The user doesn't have the row. Admin user read permission, false, symbol read. That's not true. User that rows with some row, console the row. The row is having admin. Row dot permissions. And the permissions here we have to array that includes permission. Whoa, and it's working. It's working. What? So this is what we were supposed to do, and we're getting the cabloy. Actually, oops, cabloy again. Parenthesis, not parenthesis. What is this? Expression expected. Return. Is this? Where is you express? Why are you telling me this? We have a messed up things. So rows of permission that includes permission. This is a function. Okay, let's remove this. Okay. Let's see. Okay. JavaScript is frustrating, man. So I love TypeScript. 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 Yes. True. Oh my God. And this has been giving us tough time. Where to take, oh, Cabri. Oh, can have access, can have access. I'm messing up since myself. Don't worry, we're going to go over this again. I'm just trying to get things right here. True and false. We have gotten it finally. Holy error. Yes, let's go over this and try to understand what's actually happening here. Okay. Oh, calm down. You are too excited. Okay, I kiss. Actually, I'm excited today because I am strong. Okay. The row, we have a row here. It's an object actually that takes in a name and a permission. Permissions. Yes, because it's an array of permissions. So we create a permission, a symbol of permission, read and write. You know, symbols are unique. So you cannot have collision issues even if you do them twice. So assign an admin row to the new row with an admin and permissions of read and write, which you created as symbols, and they are unique. So you cannot tamper with those. So we have a user row with new row user and a read permissions. Actually, then we created another object of a user where a user can be able to access those rows we've specified earlier, the admin row and the user row. So in our system, an admin user can read and write, while the regular user can only read. So we have a function here that define these rows and apply them to our system. So we'll try to access this. We've defined a function here that returns the user rows and try to check if a user can write or a user can read. And we check if an admin user can read and it returned true, because the reason why we're using read here, because even if we use write, it will still return true. If you use read, it will still return true. And admin can actually read and write. Then we have another one, a regular user. We give it a write permission, but actually a regular user cannot write to our system. So we've actually used symbols here to create permissions, because we know that symbols cannot be overwritten because they are very, very unique, and you cannot override symbols. Wow, wow, wow. And this is sweet. Is there any confusion here in this our application, or you need more time to explore it and really understand what is going on? Because we've combined what we learned previously and the function constructors and what we're learning today. Yeah, Joshua, you can go on.
Okay, there are many things that are here that I don't know, but I'll explore it. But this line, please, can you scroll down a little?
Okay.
This line 21, user.roles.sum. That dot sum, is it a
sum is a higher order function in JavaScript that returns true if an array has specified elements in it.
Okay, so is a callback function.
Yes.
Okay.
Let's say we have an array of numbers 1, 2, and 3. Then we say log numbers that some number, return this number if it's actually in the array. And let's no, we're not supposed to do this like this. Let's say let number equal to, this is correct. Number that's let me make it a function. Check num, and then you return, you pass in an array of numbers, and then you return numbers that some num.
Okay.
Okay, validity index. If only accept it's actually returning. Oh, let's make it like this. Why is this? Let's pass in the, okay. I'm seeing true and false. Is there any log? Okay. Take this out. Just call the function. Node test.js. Testing another thing altogether. Log.
Okay.
True.
Yeah.
Let's say sum. What we actually want to do, is number divided by 2 is exactly equal to 0. We want to check if any number in the array at all is divisible by, like, if divided by 2 is even. Let's say it's even. We want to check if any number in the array at all is even. So we just run the function. And it's true because 2 is even. Let's make 2 7, and then false because no number in the array is even. You understand how the sum function works? It returns true if any element in the array is applicable to the functionality we are specifying. Like you see, any function, any criteria at all. We may say, let's if a number times 2 is exactly equal to first element in the array. Oh, what is this? No. What is the first element in the array? Let's make it a 6. And let's see if this works. True, because 3 times 2 is 6, and the first element in the array is 6. So any number in the array multiplied by 2 is the first element of the array is equal to the first element of the array. It returns true. So that is how the sum function works. Okay. And I think with this, we've clarified on your question,
sorry.
right, Joshua?
No, that means that user.rows is an array, right?
Yes, it's an array.
Okay.
Look at it. Can you see? Because here, permissions, it's an array.
Okay.
User,
Okay,
rows,
okay.
it's an array. Can you see the array here? Can you see the array? Yes, it's an array. And the permissions also is an array, includes. You know how the includes work, right?
Yes.
So I think we've answered your question. And let's move. We don't have enough time. Let's move to exercise 2 and try to brush over it. Symbolic configuration manager. Symbolic config manager.js. Okay, so we're going to build in a symbolic configuration manager. And what does this do? It allows you to store and retrieve configuration values. Yes, using JavaScript. That is typically what it does. It will involve, we'll create constructors, yes, and use symbols to prevent accidental property conflict so that you understand how symbols really work. Let's dive into doing this. Configuration, okay, let's say config manager. Then we simply say this, that's configuration. This is configurations of, what is this? Is equal to new map. You know what a map is? I don't think some of us don't know what map is. But then we'll talk about map later if we have enough time. The prototype, we're adding a method to this configuration manager that sets. Yes. It's equal to a function. You see, config config symbol is equal to symbol. What am I doing? Symbol key. And where's the key coming from? The key is coming from this function key value. So you take in a parameter of key and a value, then we say, while actually setting this key. So this that configuration, these are configurations that set. You know, this is a map. Say a map has a method of sets on it. So we're calling that from the map. It has a key value, add a new element to the specified key and value to the map. If an element with the same key already exists, the element will be updated. Wow. So that is cool. And then we say config symbol and then key. What is actually going on in this set method on this configuration manager object is we're adding this method to the prototype so that any other instance can be able to access it. And we're passing in a parameter of key and value. Then this key, we are converting it to a symbol, then setting it to the map as key and value pairs. But the key is a symbol and the value of value here, not key. Yes, key value pairs. Then we add another method. to the configuration manager, that prototype, that this time around we actually want to get, not set, is equal to function. We're going to use the key to access it. But this time around also const config symbol is equal to symbol key, and we're converting the key to a symbol. Then we are returning because we are getting, so we need to return it and pass it to the execution context and say these are the configurations that get config symbol. And this is what we actually do. It we get the key, get to this set, and retrieve the value of the key passed into this function. So let's just use it. Const config manager is equal to new config manager. Oh, our manager is here, configuration manager. And it actually did not take any parameters, so we're going to leave it like that. Then we say config, we set config, test config manager dot add. What is that set, not add? Mistake. I don't want to get a Cabli AP. Let's say we're building an authentication system, or we have a platform that people register and get API keys and then get to call it in their application or perform some kind of functionality that they need to get access to our API, but they need an API key for us to be able to identify the specific user. So this is API key, and we want to pass in some gibberish, some my API key, or you can simply write API key test cm dot set. Let's design. Let's set a design system. Let's say yes, username to some, okay, so Joshua, yes. Then we'll just simply log configuration, let's say test dot get, what am I doing? Dot get, what is this? API key. Let's copy this and paste and say this time around we want to get the username. Then we log it to the console. Let's see. No. That is not what we're trying to test. Node. The name is still long. Symbol. Hey. What is this? Symbolic. Hi. Config manager.js. Oops. And it's actually returning undefined. And why is it returning undefined? Username API key. Set a key, new API key. Config symbol key dot get config symbol. This is a map symbol key. Configure set config symbol key and the value. Yes. You're returning these that configurations that gets config symbol. Okay, created an instance. We try to set an API key to value key username. So it's wrong. Let's get. It's an instance of the new configuration manager. Use its configurations, go to new app. It's returning undefined. Okay. This takes us to another session of debugging. Yes. We've actually got these values. The API key, the key is API key, and the value is this. The symbol username has Joshua. Our application is working. The configuration has two values in the map, and the API key maps to this. The username maps to this. What is actually working? Well, sorry, what is actually happening? That we're not getting back our API key that gets the key. Config symbol is equal to symbol key. This does configurations on get config symbol. Okay. Debugging session. Debugging session. Undefined. JavaScript is frustrating. That's why I love TypeScript. TypeScript. I love TypeScript. I love TypeScript. We should really config simple key return this get. House. And I'm actually, oops.
Please, can you scroll to the report?
Yeah. So actually the set function is working, but then prototype.yes, no typo errors. No typo errors. Configurations.get. But this is simply supposed to return this value and Joshua. As you can see, if we log this to the console, it simply the object simply returns the symbolic key with a value of this and the username with a value of Joshua. But then when we try to log it to the console, it returns undefined, and I don't know why, but because it's supposed to work. But that's by the way, we'll come back to this. For now, let's move to iterators. Whoa. Iterators in JavaScript are objects that provide standard way to iterate over collections or sequence of data, their interface is defined with a next method that returns the next value in the sequence along with a down property indicating whether the iterator is complete. And in iterators, we're going to be looking at iterable, iterator, and same way, maybe we look at the custom range iterator, and then maybe if we have more time, we'll look at the character analyzer also. But if we don't, we'll just look at the custom range iterator. Okay, so now what is an iterable? This is very, very tricky. And if you don't pay attention, you would understand, but we'll try to play around with it so as to get accustomed to this iterable and iterator something, because they're very tricky to understand and get used to. So an iterable is an object that has an associated method. It has an associated method, the symbol.iterator, symbol.iterator. Remember, a symbol has a property called iterator. So this is a method in iterators known as symbol.iterator. When this method is called, it returns an iterator. And in other words, an iterator is an object that can be iterated over, and it knows how to produce an iterator. What's that? In other words, an iterable is an object that can be iterated over. Yes, because it is iterable. Am I pronouncing it correctly? That's by the way. Because it is iterable, it can be iterated over. And that is wow. Can you really iterate over an object? No. Or an iterable can be iterated over. That's kind of funny. Let's try to look at what an iterable is. And let's try to say let's say custom CI. I'm tired of typing this. CI, and then we give it a data, the key data, and the value of 2, 4, and 8, 2, 5, and 8. Then remember, an iterable is an object that has an associated method. So the next thing we're going to do is the method. We're going to define the method. Symbol.iterator. This is the method. This is actually a function. This kind of defining functions like this, like let's say next, something like this, was introduced in ES6, but you can only use them in objects. These kind of functions, you can only use them in objects, so don't get confused. This is actually a function, but why is this function like this? Well, in this case, this function doesn't have a name. It's actually a method, symbol.iterator. So what we want to do is we want to iterate over the data array in the object. So we specify an index and initialize it to 0. We declare an index and initialize it to 0. And then we will return an object that has a next function. This next function will take an anonymous, this next property will take an anonymous function, which is actually a method. And then we try to check if the index is our index less than this, the data, where this is returning to this very object, this CI object. So the CI object has data. So if I say, is our index less than the data of this CI object, that length? I don't think so. Our index is 0. But if it is less, then you say value, the value of this CI should be this dot data. Always remember that the data, this is returning to this object, and this is returning to this object. The data of this object is this. So this dot data, that is the CI dot data. This is referring to this object. This is referring to this very CI object. This is referring to this CI object. And this CI object has a data of an array 258. Yes, yes, and yes. Index plus plus, that's increment index by 1 every time you check and you see that the index is still less than the length of that array. Increment it by 1. Increment it by 1. Yes, yes, yes. And we're actually going to return this and make it an object. Yes, make it an object, because this is not the only value this object will be returning. This is not the only, it will also return a done that will be initialized to false. Yes, anytime our index is less than the length of our array, increment this index by 1 and the done should be false. If you increment, first time the index is 0, the array will return 2. The next time the index, you increment it by 1, becomes 1, array becomes 5, increment it again, array return 8. Then, but what if then the index is equal to our array length? We say else, if the index is equal to our array length, what are we going to do? We're just going to return done to true. Wow, this is sweet. Is it not sweet? It is. Then we want to iterate over this object. And this is sweet. Say for const item of custom. Oh, CI. I never wanted to spell that info. CI. Log item. Don't give me a cable, please. Don't give me a cable. Don't give me a cable. CD iterators. And then you test your tests. That's just. Yes, and it's working. It's working. Sweet. As you can see, we're iterating over our object. Can you see this? Can you see this? This is sweet. Always remember, an iterable is an object that has an associated method called symbol.iterator. This is what is performing this magic. This is what is performing this magic. You can even say log symbol.iterator. Let's see if we get a cable. Symbol.iterator. It has a method symbol.iterator. The iterator simply iterates over objects, over items in an object. Yes, let me not confuse myself. Then let's move to an iterator, because we've seen how an iterable is. An iterable is simply an object that can be iterated over. Get this concept right. An iterable is an object that can be iterated over. Yes, we have iterated over this and we've gotten the values 2, 5, and 8. So it's an iterable. So how do we implement this? Look at this. It is sweet. It is comment this out and move to iterators. Iterator. Whoa. And what is an iterator actually? An iterator is an object that represents a sequence of values. Yes, values, and tracks it's currently positioned within that sequence. It must provide a next method that returns an object with 2 properties. Yes, 2 properties. A next method. Remember methods in objects. Always remember methods. These concepts are sometimes confusing. A method that returns 2 properties, the value and the done. The next value in the sequence and done, a Boolean, indicating if the iteration is complete. The iterator is responsible for keeping track of the state during iteration and advancing to the next value, the next, yes, when next is called. When you call next, it moves to the next value. When you get to the end of the data it's iterating over, done will become false. Then it will stop. It will stop. It will stop. It will not go further. So let's see how an iterator works. Simple iterator. Oh, this is sweet. So that make it, yes. Lowercase, yes. And let's say values. Let's see, we should say data. Data. It's an array. 1, 2, 3, 4, 5. Yes. Then we see index. We specify our index to 0. Yes, our index is 0. And then we remember an iterator is an object that represents a sequence of values, and it must provide a next method that returns an object with 2 properties. The next method that returns an object with 2 properties. The next method. So let's implement the next method. Always remember about this function I told you it was introduced in ES6 that can only be used in objects. It makes code simpler to write and more cleaner. So what we're going to do is we're going to check if is the index less than our data.length. If this that index, and remember this is referring to this simple iterator. This is referring to this simple iterator. This is referring to this, and this simple iterator contains data and index properties. So if you say this, you will see them pop up. This, the data, the index, and the next. So this object contains 2 properties and 1 method. And the method we are working on right now, the properties we've implemented. So let's say this.data.length. If the index is less than the data.length, what do we want to do? We want to actually return the value in the array, a single value. So what are we going to do? We're going to return an object that contains 2 things. Remember when we discussed earlier, we said it has a method, a name method that returns 2 properties, the value and done. So in this case, we want to actually return the value of this dot data. You know, data is an array and it can be accessed using offsets or indices. Offsets. Okay. And index plus plus. By the time we start iterating over, index will be 0 and it will return 1. The next time index will increase to 1, it will return 2. And oh, it is sweet. And then we set done to false. Wow. Where's done false? We'll talk about that later. If the index is less than the data length, and we do this. Else, what do you want to do? We want to return done to true, so that it will actually stop iterating over this. Can you see the difference? This has a method of symbol.iterator. The method is symbol.iterator. Do not forget. But this method is next, not symbol.iterator. Next, not symbol.iterator. Okay. You can actually iterate over this. What you want to do? We want to say for const item of is that what you want to do? No. This is not an iterable. That's not what we want to do. We want to simply log simple iterator dot next. Next is a method, so we call it. Then we log this to the console. We are getting the kablooey. These are data index is not defined. These are index, these are data length. Where are my iterators? Test.js. This is index value. That's data. index plus plus done false. What is this? Index is not defined. Index? What?
Yes, on line 26, instead of this dot index, you type index.
Oh. See, I love TypeScript. Thank you. I love TypeScript. TypeScript will yell at you. No, you are wrong. I will say value 1 and the down is false. We call it again. And this time around, we get value 2, the down is false. Call it again. Can you see what the wonders this is doing? It knows when to pause and when to continue. The next, it's iterating. The next function will simply increment the index and output the next value in the array. And this is sweet. And you keep, let's say we have how many? Let's reduce this to 3. It's too much. Do it again. 3, down is false. Okay. Why is down false? See. Down true. Yes. Because we've iterated over all the values of the array in this object. And as you can see, yes, Jamba. Oh, your name is Jambauda. You can go ahead.
Okay, thank you, sir.
Yeah.
As for these iterators now,
Yeah.
we have the next method. Can we implement previous and seek method so that it will just look like a double linked list?
Yes. But that has nothing to do with the iterator. The iterator is supposed to be very, very simple. You know what an iterator is? Aside programming, let's say in English, you know what an iterator is? It actually iterates. Oh my God, what am I saying? It actually iterates over a couple of items and returns their values or something like that. I don't know what it means in English, but I'm trying to explain that. The iterator will try to iterate over this object itself and return the values it has. What value does the object has? It has these values in the array. But iterating over and trying to implement, you can actually implement linked lists, doubly linked lists or single linked lists with iterators. And it is fun doing that, but that has nothing to do with what you are doing here. We're just trying to understand iterators. And if I try to explore them beyond this limit, some people will get confused. And moreover, we're going to be building a simple project on this so that you understand it in depth. So as you can see, as we got, the index got to the length of this array, it simply returned down true. I can simply do this again and let's see what it returns. Down true, because the index is equal to the length. So we are not going to return anything. We're just going to be returning true, and true. So this is how the iterator works. And this is the iterable. Note the difference. The iterable here, these objects can be iterated over. Can you see this? For const item of CI, we're iterating this over this object and returning an individual value in the array. But this is different. We cannot iterate over this object, but we can iterate over the data of the object using the next method. Wow. Is this not sweet? This is sweet. Oh my God. So these are simply iterators. In iterators, you just need to understand iterable and later we're going to be looking at how we can use generators to simplify the iteration protocol. And that is in a few minutes, we'll get there. So right now, what project are we going to build? Custom range iterator. And I think we're just going to build a custom range iterator. The character analyzer is fun. Oh my God. We can't wait to build that, but we don't have time. We just build a custom range iterator and it is sweet. Very, very sweet. Let's get to see how the custom range iterator works. Similar to what we've done, but when we build this, just like applying it to build something. something custom range. Another long name. But JavaScript says, oh, you're a good programmer, you need to make your file names descriptive so that you can be able to know what this file stands for. Oh, that is somehow sometimes frustrating. So we want to, in this custom range iterator, we just want to define a range iterator, a range. When you specify a range in it, let's say you give it a range of 1 to 5, it will iterate from 1 to 5 and stop. So that's simply what we're going to implement. So we're going to say function range. Let's just make this a complete name, but it's frustrating, you know. We'll give it a start and end. Start and end. What are we saying? We're saying current is a start. Current is actually 0. Let's say if the start is given as 10, current becomes 10. Yes. I don't need to be explaining all this because we have the basic knowledge of this frustrating language, JavaScript. Without TypeScript, JavaScript will frustrate you. So now it will return a single method of next. What is next doing here again? Because it's going to be iterating. Yes, it's an iterable. So we're going to be iterating over this object, giving the starting and the end. It's a range. Yes, it's a range. So next, if current is less than or equal to end, the end is the stopping point. Oh, yes, the stopping point. Return value current plus plus. When I started out in programming, this used to confuse me. Yes. What is current plus plus? Current plus plus is simply current is equal to current plus 1. Yes. Anytime it gets to current, it will increment current. It will take current, let's say current is 2, and it will assign it to 2 plus 1. Becomes 3. Current here takes 2, current is 2, takes 2, add 1 to it, making 3. Comes again, done is false, takes 3, add 1 to it, 4. So this is what this is basically doing. No fancy stuff there. It's as simple as it is. It's a else. It should return done to true. Sweet. And when it gets to the end, if current is less than end, this will return true. This will evaluate to true here in this block. This will evaluate to true and this will execute. So by the time the current is less than or equal to, by the time the current is equal to the end, it will evaluate to false and this will execute. It will simply return true. Is this not sweet? It is sweet. So how can we use our function right now? You can say const iterator is equal to range. What are you giving me? Range iterator. What are we passing in the start and the end? Let's give it a start of 23 to 30. Yes. 23 to 30. Then we want to iterate over it for const number of iterator. Just bring it to us. We want to see it, and don't make sure you don't give me a tabloid because JavaScript, don't give me a tabloid. Do not give me a tabloid. What am I calling? Oh, no. Node custom range.js. Oh, what is this? Custom range iterator. Oh my God. Iterator.js. Iterator. Let me see. What is it saying? Iterator is not iterator. Oh my God. Are you serious? You say iterator is not iterable? How? How? Just return next. Hey, hey, hey. Yes, yes, yes. It is not. It is not. This is an iterator. This one is an iterator and not iterable. So we got too excited and then we thought what? Next. Oops. Next. Yes. We became excited and did something different. Oh my God. I'm sorry about that. Sorry about that. Sorry about that. Yes, 24 and done is false. Okay, let's take this to 23 to 25 so we can be able to get what we want. False. Do it again. So then we get, yes. Return done to true and you are returning undefined. Return an object of done true. That's why it's returning undefined. Yes, done true. And what it? So, you know what we're going to do? We're going to comment this out. Actually, copy. Oh, let's comment it. Copy it, comment it out, and try to. Oh, yes. What we're going to do here? We're going to convert this to an iterable and see how it works. Oops, time is not on our side. We're done with the custom range iterator. And that's simply how iterators work. We're able to implement a custom range iterator with our knowledge of iterators and iterables. But this is simply an iterator and not an iterable because you cannot iterate over it, but you can iterate over its elements or over its data using the next function, and that is sweet. But when working with these iterators and iterable, you have to be very, very cautious. You have to be very, very cautious. Yes. And that is where generators comes in. Generators. We can see how we use generators to simplify how all these implementations are being done. We can see how we can simplify that. You can actually go and research about the character analyzer and make sure you play around with it. If you can get it anywhere, I don't know if you can get the character analyzer anywhere, because these are special kind of projects. Well, maybe somewhere. The internet is weird, so you can actually get it. Sure. So let's move over to generators. Generators. This is not actually a generator that generates lights. No. Generators are special types of functions in JavaScript that can be paused and resumed during execution. They enable writing asynchronous code in synchronous way using iterators. Can you see the end? The end. What is it saying? It uses what? Iterators. Wow. Generators are simply functions. They are simple functions that are defined as a special function using a special function syntax instead of the regular function. The regular function keyword you add an asterisk at the front of the function, something like function. This is a generator function. A generator function. Once you add this to the front of that function keyword, it becomes a generator function. Yes. Then we are looking at trying to break it down. It pauses and an execution and resumes an execution. That makes it awesome. You know, personally, in generator function, you can use the yield keyword. Yield. When the generator encounters a yield keyword, it pauses the execution. Yes, when it encounters that yield keyword, it produces the result and then pauses that execution. It's like saying, I'm temporarily stopping here, and here's the value I want to give you back. Yes. Today, I want to close from work today, and here is the result of my work done for today. So have it. Tomorrow, when I come, I will resume this execution. And when you call a generator function, it doesn't run immediately like other regular functions. Instead, it returns a special kind of iterator called generator iterator. Oh God, can you hear that? An iterator is a generator, but it is called a generator iterator. You can use the iterator's next method to start and resume a generator execution each time you call the next method. Yes, the generator runs until it reaches the yield statement. That is where it pauses, or if there's no next execution, it terminates the function. It actually remembers its state. Generators remember where they left out off when they pause. They return their local variables value. So when you resume the generator, it continues from where it paused. Yes, using the existing variables values. Yes, it remembers its variables. So anywhere it pauses, when it wants to resume, it remember its variables and it resumes execution from there. Multiple pauses, it can, generators can be paused and resumed multiple times. You can call the next on the iterator repeatedly, and the generator will keep running until it reaches the yield or until it is done. Can you see that? The next function, you call it till it reaches the yield or until it's done. Generators are actually great. They are great. Great. So let's see how we can implement generators. Let's say a number counter. This is not a regular function. This is a generator equal to 1. Why true? This will always return true. You can use Y1. 1 is true, not return true. If you use 0, 0 is false. And it will not run. 0 is false. Why true? Yield count. This is a while loop, and if you don't increment this, what are you going to do? What's going to happen? You don't increment this, it becomes an infinite. Actually, an infinite loop, but this is a generator function, and it has no implications. The only thing you need to do is you keep calling it till you get to where you want to go. You see, const counter is equal to, yes, call the function. And what are you seeing? Okay, let me show you again. Whoa, generator. It's a generator function. So it's a log counter dot next dot value. Whoa, isn't it sweet? It is sweet. Hopefully we don't get a cabloy. No, we're getting a cabloy because it's not actually some range. Eliminate this. And what? Yes. This next turns value current. Done, false. I want to show you something. Log iterator dot next dot value. Can you see this? So this whole logic as implemented here. Can you see? Look at the whole logic. Now, okay, let's run this function again. I want to just show you something briefly. As you can see, the value here is 24. Yes, next dot value. If you comment this out, then you can actually say, oops. Yes, you can actually say, no, this is not what I want. You can actually say log iterator dot next dot done. You see that done will return false. Yes, you see 23 and the done is false. Yes, yes, yes. And generators, let's switch over to generators. CD generators. Yes, and we're in it inside the generators test. Yes. One, is that not wonderful? We don't want to console log one. We just want to see the next function, what the next method, what it holds. Can you see this magic? Generator functions. We don't need to go over implementing iterators and iterables and all of that logic. We just write our logic here. While true, yield count, what? Return count. In this case, the yield is simply returning the value to the execution context. Return count. As simple as that. We don't need to disturb ourselves, worry ourselves, writing some kind of logic next if value is less than index, if index is less than that one. No, just define your generator function, write your logic, and get out. Okay, so you know what we're going to do? We're going to solve a simple exercise with the generator functions, and then we're going to call it a simple iterator, but this is going to be using generator functions. Say function with our this simple iterator values. Is that not awesome? Values, values. Select index equal to 0. Then we see this is very, very simple and clear. Why index is less than values dot length. Oh, yield values, not the values, but the value at the current index, and that is index plus plus. How? Oh my God! Can you see how simple this is? Come to this place. See, look at this. All we had to can you? How many lines of code? About 16 lines of code. 16. No, in generators, all you need to do. How many lines? 7 lines. 7. No, not that one. 7. This is not even up to 7. 6 lines. 6 lines, and all you need to do is just come over here, give it your values. You don't even need to specify the values inside the function. They will be outside. 1, 2, 3, 4. Then you come here and then you see const iterator is equal to simple. Then you pass in your values. Then the next thing you're going to do is log iterator dot next dot value. No, what we're going to do is simple iterator dot JS. I return 1. Maybe you don't want the value, you want the done. You actually want to see the done. False. Done is false because we haven't gotten to 4. And you don't want to see you just want to see the object that contains these values. Value 1 done false. And this is sweet. You don't need to go around worrying about iterators, iterables. This is sweet. Add more. Check it again. Value for done false. And here the value is actually undefined and the done is true. Yes, the value is actually undefined and the done is true. Yes, and that is sweet. And you can also come over here and do something like value undefined. Oh, let me uncomment this. Value undefined and done true. this is Iterators node test.js. An error here. Okay, actually, I wanted to comment this out. It's not the one I want to work on. Comment this thing out. Yes. Save it and run it. No. Can you see this? And it's behaving like the generator function because the value is undefined and the done is true. But in generators, you don't need to specify these things manually. The generator function actually returns everything for you, and you can do whatsoever you want to do with it. And we've come to the end of our class. We've learned a lot. The iterators, iterable, the symbols, and the generator functions. We've learned how we can use them to build simple projects. Actually, we never had enough time to build the text analyzer using the iterators and iterables, and also build it using the generator functions. But you can experiment that if you want to, and believe me, it is awesome. So any questions before we call it a day? Any questions, anyone? Okay, so we can actually call it a day and see you again Thursday. Thank you and goodbye.